This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
At Collide, we know end users are IT admins' most significant untapped resources and key to solving the most challenging to fix security issues, including instructing developers to set passphrases on unencrypted SSH keys, finding plain text two-factor backup codes and teaching end users how to store them securely, convincing employees to uninstall evil browser extensions that may sell their browser history. Visit collide.com/SERadio to sign up today. That's KOLIDE.com/SERadio. Enter your email when prompted to receive your free Collide gift bundle after trial activation. You can try Collide with all its features on an unlimited number of devices for free for 14 days. No credit card required. Try it out at collide.com/SERadio.
This is Jeremy Jung for Software Engineering Radio. Today I'm joined by Chingunde. She's the VP of Engineering at Render, and she previously managed a team responsible for compute at Stripe. Before that, she was an engineer and manager at VMware. Welcome to Software Engineering Radio.
Thank you so much for having me.
So today I thought we could talk about the experience of building a platform as a service. And so where I thought would be a good place to start is maybe defining what that actually means. What is a platform as a service and what problem is it trying to solve?
I think the term itself has not existed for as long as people realize. It has also been used in kind of like different contexts. So to kind of share it a little bit, I think you have to kind of talk about the ecosystem. So you have software as a service. And the way I think of software as a service is when you're actually just running software online without having to download something to your local system. And so that's software as a service. And then at the other end, you have infrastructure as a service. And that's most of the cloud computing providers. So for software as a service to exist, you actually first need infrastructure as a service to exist, because that's what all SaaS companies run on top of usually. And then in the middle is this kind of other layer that has kind of been built on top of infrastructure as a service, which is the platform as a service. So imagine you are a SaaS company and you want kind of like, you end up either internally building your own platform, which you're then providing as a service to all the other engineers at your company, or you are relying on a third-party platform. And that's kind of where companies like Render come in, which is you are providing a platform where you're providing a certain amount of abstraction, like essentially software development abstractions for building your code, writing your code, usually using open source components, building on top of GitHub or GitLab or similar, and then having some sort of standard components such as an ability to deploy your code, run your code, again, as a service. And that's something that provides all of those wrapped up is what I like to think of platform as a service. So the additional thing that it's providing that differentiates it purely from infrastructure as a service, in my view, is infrastructure provides the kind of nuts and bolts. So, it provides things at a layer of compute, or you're getting memory and compute, or a virtual machine, or at the next layer, and this is kind of where maybe the boundaries get a little blurred, like are you getting a cluster, are you getting a container? But at some level, that's still all of it is infrastructure. And then things on top of that are the next layer is platform.
You mentioned infrastructure as a service being provided by companies like Amazon and Google, providing you virtual machines or maybe providing you a way to run containers. And platform as a service would be a layer of abstraction on top of that. So not working directly with those things.
Yes, exactly. That's more the way I think of it as platform as a service is the tools to develop your SaaS software, but that provide kind of higher level of abstraction than pure compute or memory.
Companies that are running the big infrastructure as a service products like Amazon, like Google, why don't you think that developers use what they already provide? Like, what is it that they're missing that has to be served by companies like yours?
To kind of answer the question, I like to kind of, go back a little, nerd out on the history of cloud computing a bit. And this kind of is informed a little bit by the fact that I used to work at VMware. So VMware they were not the first, but they were like one of the major providers of popularizing the concept of virtual machines. So before that, you only had physical servers or laptops or desktops, but like everything was like physical. They introduced this ability to kind of slice up parts of your physical server and create essentially virtual machines. So the ability to run independent, isolated systems within one physical device. And that became like virtual machines. And that kind of led to cloud computing because now Amazon and Google and Microsoft could kind of, provide these virtual machines online. And so slowly everything the entire data center, which used to be like physical hardware, became virtual and essentially got moved to the cloud. But in that, what happened was all the complexity too got lifted and shifted. So, the complex networks got lifted and shifted. Everything was just moved together to the cloud. When you today go to Google or Amazon or any of the cloud providers, in many ways, it is not that different an experience from buying a physical server and racking and stacking and there is some level of ease that has been introduced because it's all virtual. You're not actually going to a physical store and like running cables. There is that level of abstraction, but the concepts themselves are still essentially physical concepts virtualized, with some basic level of simplification added. And now, so if you take that metaphor a little further, what developers, engineers, builders of products need is more than that. They need the dev environment. They need a lot of other things on top of just pure servers. If you kind of compress all of that into one product, that's that layer that we are building.
This layer that you're building on top, are you building it on top of an existing cloud or are you running your own servers? And how did you come to that decision?
So currently we are building on multiple clouds. That is what we're doing. The way we came to this decision is that the underlying cloud provider is sort of commodity at this point, and things like Kubernetes give us enough of an abstraction that we can actually build on top of an existing cloud provider and then also introduce on physical data centers under the hood. And we have kind of experimented with it, but we don't have full production level systems running yet. So that is part of the plan, but it isn't there yet. These abstractions allow us to actually run on a particular cloud provider and then create a similar cluster on a different cloud provider, and then also then move that same workload to bare metal eventually. But that's kind of how we're doing it. How we kind of came to the decision was, so this was before my time at the startup. I've only been there a little over a year, but I kind of know the history, which is I think the original thing was the core competency that we're providing is this developer experience, is this platform. So the ideal goal was solve for that and then work down the stack instead of trying to build from scratch. Why reinvent what has already been done at the lower layers? Instead, try to build the differentiation at the higher layer and then work back down.
So it sounds like from what you were describing is you're starting out with a software that can run on basically any virtual machine on any server, and you're running on top of public clouds with this sort of testing in the back where you're trying to see if we needed to run our own servers, could we move those workloads over to them? And so maybe you get started running on these public cloud providers, and as you grow, then maybe you could shift to bare metal to either for cost savings or for other reasons.
Exactly. That's kind of where we are. There's many different reasons. Cost saving would probably be the less interesting one. It would be kind of, providing options for our service in places where the cloud providers may not exist. Something that has kind of become more interesting in the more in the last few years has also been regulatory reasons, where a lot of countries are introducing regulations where they want companies wanting to serve their citizens to have a physical presence there. So there's many different reasons. And so we think that there will always be good reasons to explore that space.
Do you have any concerns about these other cloud providers building what you're providing? AWS goes oh, let's see what Render's doing and we'll make our own version of that.
I think for better or worse, I think that's something that most SaaS companies have to deal with. I think you can probably like between the three major cloud providers, you could actually credibly always ask this question, right? Like if you're building on them, can they in turn build the same product? And I think that always exists. And I think saying that that's not a possibility would be kind of naive. But that being said, they haven't done it yet. And I think that's kind of, why startups have to exist. And you could say the same thing for like many other companies. Like, in fact, this used to actually be a relatively common question asked at Stripe, which is like, what if Amazon gets into payments? Like, will they take over our business? And so far they haven't. And I think that's where I think you have to be very clear about the direction and the differentiation that you are providing, which is where kind of it goes back to the origin, which is we're not immediately trying to go build from bare metal. Our focus is developer experience and the developer platform, and that doesn't yet exist. And the plan is to get really, really good at that and be the preferred place for all developers to build.
Yeah, and I suppose, like you said, it doesn't currently exist. So if they were to come onto the market in a few years, you would have a, X number of years head start as well.
And I think this goes back to kind of, like the differentiation and the moat. You want that head start. You want the stickiness where users, have workloads on us, have like, their startup working on us, have really like grown to trust us and have grown to love our workflow enough that they would seriously consider like, a point of friction to be forced to move to the other place.
So we've talked a little bit about how Render is a platform as a service to allow developers to run their apps and not have to worry necessarily about specific virtual machines, specific containers. And I wonder if you could talk a little bit about how you're running those applications. You mentioned Kubernetes briefly earlier, but I wonder if you could elaborate a little bit more on what's happening.
I can't go into too many details just because that's a bit of the secret sauce. At a high level, like, kind of like trying to answer the question in as much detail as is okay, but without revealing too much. I think in this case, Kubernetes is more of a tool. It allows abstractions for us, like it allows us to abstract this layer between virtual machines and user workloads in a clean way, which allows like, things like ease of migration, things like spinning up additional clusters. That's like a primary thing, and that's kind of why we use it. So I don't want to index too heavily on, that's the underlying kind of, mechanism. It's a tool that solves a purpose, much like the way the underlying cloud provider is solving the purpose. It's a way to kind of, build that abstraction. At a really, really high level, what the underlying product is building this thing where we're abstracting. So when you as a user don't have to think of your compute and have to think about where you want to run your service and where you want to kind of, you're not thinking from a provisioning workflow. So what we're doing is we're creating an abstraction where you're removed from the provisioning workflow and instead have to deal with the developer workflow. And that's really the gist of the overall platform. So, you're thinking at the level of writing code in GitHub. And then it's linked to your Render account. And so you create a PR and then you use preview environments or similar, and then you deploy your code and it goes live. And the entire layer of the product is actually just that, which is like managing this workflow. I guess that's kind of like the level that it's possible to do it at without kind of drawing an architecture diagram. But we're kind of like essentially shepherding the user's code using their workflow instead of being like, okay, now click on create a virtual machine and now copy your code from your desktop to, or like your Git repo to this place and now run the binary there, right? Like we're essentially just like packaging all of that into the developer workflow.
Like, I guess in our initial email conversation, we talked a little bit about being able to talk about the parts that used open source or which you built yourself and where you partnered with other providers. And I'm wondering, like, out of those different pieces, if you could talk to, as an example, like, oh, these are the things that we use that are open source and these are the things we decided we needed to build ourselves. I wonder if you could talk about a few of those things.
Yeah, I think one example, because it's somewhat recent, that I could talk about would be, I think because it's also like a differentiation that we're providing is partnerships. So one thing that we did very recently is we actually decided to we realized that enough of our users were vulnerable to kind of like, security attacks or mostly also like DDoS attacks. And so it kind of actually became kind of like an interesting question for us, which is, do we continue solving these either as incidents, like, where this happens and we mitigate it live, which is actually possible to do, which is what we were doing until that point. Do we use what cloud providers provide also as a service, or do we use someone independent, or do we also actually just build the capability ourselves? And I think this was an interesting exercise of a sort of a build versus buy model for us. What we decided was that this was enough of a problem, or if we were successful, this would become enough of a problem that it would make sense for us to become really good at early. But it was also not the thing where we would necessarily be differentiating ourselves, because our core is the developer workflow and providing the best developer experience and being the best platform to run on. And there are companies that do this full-time as their core business, and that's kind of where we evaluated basically a few different vendors, including the cloud providers themselves, and then decided to actually pick Cloudflare as a vendor. And so all our user workloads, everything is behind Cloudflare, and that kind of gives us this protection. And then there were some interesting discussions around pricing, which is we are paying for it. Do we pass that cost on to our users, or do we actually offer it as a benefit? And then we decided that at least for now, we will actually offer it as a benefit, so that it kind of goes with the concept of we're a platform. And so you shouldn't have to think about individual components of the platform. And this level of security and DDoS protection is part of the platform. Basically, this makes the superior platform, but as a developer, it's not something you want to be thinking about. And so it's baked into it directly. And I thought that was an interesting exercise, because as part of that, we actually rewrote the way traffic gets routed to Render. And we actually have a couple of really good blog posts on both pieces of this, which is using a vendor for DDoS protection, and then also the way we structured our Anycast network. So Anycast is the way, is essentially how traffic comes in and then gets distributed across. And those were kind of interesting architectural decisions that we made over the last year.
So it sounds like in this example, when people deploy an application, there's a lot of, bots and things like that, just trying to hit your application that have no interest in using it, but are just wasting your resources. And you made the decision that it's important to have it, but there are other companies that are either have more people dedicated to it, or it's a problem they've been working on for a while. And so rather than you having your team build a solution for that, you decided, okay, we'll let Cloudflare handle that for us.
Yeah, that's kind of exactly the decision that we made. And we've actually had to make this a few different times. Another example was around metrics. There's many different platforms and vendors again. And I think this is actually where we use a mix of open source and also kind of a bespoke vendor in this case. We use Datadog, but then also for for Kubernetes, because we use that so heavily, we actually use Prometheus, because that's really a well understood framework and it provides a good level of abstraction. But then we're also constantly evaluating other options. So I think the benefit of open source is there's always so many different things that are evolving that, we can actually pick and choose, and kind of, as long as, we're willing to take the cost of migrating from one solution to another, you can actually always be a little ahead in what's being provided. And then because we're a platform, sometimes some of these decisions will also get driven by what do our users want. Are more of our users asking for a certain type of integration? This comes up with third-party integrations a lot. So things like, we have this concept of a deploy to render button, and we do that. We use this for say you're an open source project and you want to kind of tie in your ability to deploy that project to render seamlessly. And so we will kind of, build that integration. And that's where often the decision making goes, which is which ones are popular in particular communities and which ones are getting traction. And then based on that, and sometimes it'll also actually be determined by whether we ourselves are users of that open source project. We ourselves are developers, and the fact that, if something's appealing to us, or if we are seeing a gap in a particular offering, that's likely something our users in turn will also need. So that goes into a lot of these conversations.
So in terms of deciding what to let open source software handle or software as a service handle, you mentioned the security, like denial of service. You mentioned logging and metrics and things with Datadog and Prometheus. But I'm wondering, what are some things that you looked at and you decided these things are our core competency and we really do need to build these ourselves?
That's a good question. I think things that we decided on are actually anything that deals with sort of like the look and feel of the website, so anything that, or the dashboard itself. So like when you use render the product, anything that kind of flows from that experience, we kind of own and build, because the idea is that that's kind of, where you are. Like, you're using the product, and any sort of like interruption in that experience is for a relatively small startup. Like, we're quite design centric that way. So, we work with designers, we work with UX engineers. There's, I think, a difference, because I think it's particularly in dev tools, or generally in tools as a space, there may not be the same polish and the same kind of attention to detail being spent as you see in consumer apps. There has been a very conscious decision to do that internally. So anything that kind of touches the product's look and feel, or the developer experience itself, we are very conscious of owning. And then even like in the internals, anything that's part of like the developer workflow, even if we are using open source components like Kubernetes, kind of going back to that, right? We try our best to like, that abstraction shouldn't leak out. Like, you might know that that's what we're using under the hood because you're listening to this conversation. But if you're actually using the product, it's not like you're not deploying thinking about Kubernetes, right? Like you're just thinking about deploying your code, and having that be a very clear separation is important.
The part that's actually running the applications may be based on open source software, like you mentioned, Kubernetes, but all of I'm not sure how you would describe it, but you mentioned developer experience. So maybe the part that the user sees when, like you said, they go to the website or they push their code, and then the part that's maybe taking that code and running the workload, that's all stuff that you wrote internally and is, I guess you could say, secret sauce of the company.
Yeah, apart from like the integration with Git to the kind of developer workflow, setting up the integration, and then the preview environments is another good one where you can like actually like have a PR kind of review separately, and that's, I think, one of our actually differentiation features. So things like that are like core to that experience are like those are the ones that we invest in. I think maybe another thing to think about is we are kind of also like, experimenting with and also like providing features that are like managed databases is a good question where this boundary becomes harder. So we provide a managed Postgres as a product feature, and then we also are working on Redis, managed Redis. And I think that's managed databases is a very interesting one because we are very careful about, because most kind of stateful apps need a database and want a database, but don't want to have to manage the database. But then are we now getting into the kind of managing DBs as a product? So that's where we're like judiciously picking a couple of the most common ones that people need and want. And then that's where, the constant user conversations and sort of like the evolution of the roadmap comes into play.
So you mentioned the managing of databases, and I wonder, like, from the perspective of a company who's running a SaaS, is managing user databases, is that the sort of thing where you have to have a bunch of DBAs on staff and people who, would typically know how to monitor the database and tune and things like that? They're just watching all of your customers, or what does that actually look like from your end?
I think we're lucky, again, to be in a kind of state where a lot of that has thankfully been automated, but it is 100% is one of those things where you start going into more specialization. So it is like, it does require people to have a deeper understanding of the underlying technology versus just gluing components together. So yes, absolutely. So what we kind of have to do there is build the tooling to kind of, monitor the databases, manage them, upgrade them. That's like a common thing. So it takes us immediately from not having to worry about user state to like, we're always worrying about user state, but more at the metadata level. And this takes us to kind of, absolutely at the data level, you start having, and that introduces a complexity and a need for like, managing state at a different layer.
When you're talking about going from, like, when you worked at Stripe, you were managing compute. So I imagine that it's sort of similar to running a platform as a service, except that it's for an internal company. And I wonder if you could speak to how that compares to running an actually public platform as a service.
Yeah, I like this question because it's also one of the ways that I actually describe render often to people. Like if I'm talking to like former colleagues from Stripe or just like, people that are familiar or that have kind of worked at other large SaaS companies, which is, we're building render for the broader public. So the set of constraints is very different for one, and they both have pros and cons. With an internal platform, you have a captive market, right? Like you have a captive audience who, while captive, are also highly opinionated and are not afraid of making their opinions be known. And then also, depending on the size, so I was there from like around 800 employees to like, a few thousands. So depending on the size, what you're running also just becomes more and more critical. So the criticality of what you're running just becomes so huge, where you go from, running production level, but like moderately critical workloads, where an incident, while terrible, isn't like, isn't being tweeted about actively by hundreds of users, and then over time, it scales. So it is very much so the kind of experiences you kind of have this, everything is kind of like much more homogeneous, but feels higher stakes, especially as the company grows, because, you are kind of, in charge of it. So that's kind of like both the pros and the cons of that. You're like running this internally, you have a dedicated security team that you're working with, you have all of these kind of resources, but then the stakes and consequences are way higher. On the other side, when you're building for the general public, it's just really interesting because it's so much more heterogeneous. People are doing really, really interesting things on your platform and are asking for really interesting use cases and are, seeing interesting failure modes. So it's a completely different thing. The joy of that is you have a lot more room to experiment and try, and like, you're getting like an entirely different feedback loop. But they're also like, not captive. So, they just have like, they're there, but they'll also leave. And there isn't like this kind of clear, direct path or like, a roadmap. For instance, no one's giving us this roadmap from above and saying, this is your roadmap, go build this. That's for us to actually do, versus when you're building an internal platform, it's very, very clear. Like, this is the company's goal. These are the company's products that are the most important. And this is what you have to do to get them there. And like, that's it. And so what that allows you is kind of, it allows more speed, but at the risk of actually like, building things that are less polished. Because speed is like the biggest thing, because the underlying infrastructure team cannot be the bottleneck at a product company. When you're building for the public, your constraints are that you can't just like give something to people to try unless it's like, completely like actually ready. And it actually needs to be a fully fleshed product. It needs to be supportable. Otherwise, you'll start having incidents. But the use cases are so many more that you can actually like do it in a much more incremental way, where we kind of have the luxury of experimenting with things like free tier. That's something that just doesn't make sense as an internal platform. Like it is kind of literally free. So there is this tighter loop with your users that you kind of have as a public platform, that as an internal platform, you kind of have a very different set of incentives and constraints. But I do think that there's a lot that you can kind of borrow and replicate in both realms. One thing I've kind of leaned on and tried to become better at is this kind of, listening to users and like, keeping that feedback loop much tighter, which I can actually see having like, this skill would have actually been already good even at a larger company. And then I think there's a certain level of rigor and eye for detail that internal platform teams have, because often the critical nature of what they're running means that everything has to be way more detailed, that I'm trying to kind of bring to our smaller team. My pitch is really like, you're getting like that grade of platform. So if you are as a developer, like, starting out, but you don't have access to that internal infra team, we are trying to be that internal infra team for you.
Yeah, that's interesting that you mentioned how when you're doing internal infrastructure, the stakes are very high. And I can understand that in the case of Stripe, right? If people can't make their payments, then they're going to be upset. But I wonder, like you were mentioning, how on the public side, wouldn't it seem like the stakes would be just as high to your customers? So I'm kind of wondering how you reconcile that.
I think the difference here is our stage, like we're a Series A company. The hope is that our stakes are as high very quickly as well. Right now, though, it is that for us, it's kind of like the not all our eggs in one basket sort of thing, where like, where one is like, for instance, we already like work with multiple cloud providers. So by nature of targeting somewhat different businesses, we are operating slightly differently, where the economics of that did not make sense or will typically not make sense for a larger company. Like you'll find very few larger companies working with multiple cloud providers. They'll usually pick one and go deep on them. So there's things like that kind of end up getting built in for us that give us some built-in resilience. And then I think while the stakes are high across the board, like for us, we have so many different users that kind of gives us a different level of resilience. But the underlying point that you make is absolutely true, which is like, it is, the stakes are higher. It's that to me is just more as a function of time and stage rather.
If I understand correctly, when you are working for a company like Stripe, and as it gets larger and gets more funding, more employees, inevitably more people rely on it, and your reliability needs to go up. And of course, the end goal would be the same for something like Render, but it's very early days, and that's always going to be a gradual process.
Yeah. Yes, 100%. When you are like a payments company and you are in turn serving users that are public companies, that's just a different level of stakes than when you are a startup and your primary users are at a different stage as well.
The other comment I thought was interesting was you mentioned how the constraints when doing internal compute might make it, I don't know if you specifically said that you might have to build things slower. Was that right? And I was wondering if that's because you're also responsible for more things because you have more internal knowledge of the different applications that are running.
I think when I said that, to kind of, clarify a little more, I think what can end up happening is at a larger company, I think what you end up doing is you can actually go quite fast, but you don't often have the luxury of like finishing things or like productizing internal infrastructure. So there's often like this journey where internal infrastructure teams sort of run as like service teams. They are providing services for the rest of the company, but they aren't quite able to break through that next layer and also act as like fully functioning product teams. So I guess like the difference is that you're able to like deliver 80% of what your users need faster, but then you likely never get to that last 20% ever. Then you're kind of perpetually like, dealing with like the leftover debt of that last 20%. So that can kind of be actually like a frustrating thing for internal infrastructure teams versus you can't do that as a product company because you always have to provide your users with a very polished product experience. Otherwise, they just won't use you versus at a larger company. They don't have a choice, but then you're often also just like working with constraints such as like, team capacity and team priorities that will be slightly different. So I don't think it's more like you go faster or slower. Maybe that's the wrong characterization. It's kind of like what's the level of finish that you need to provide in both. And I actually do honestly think that most internal infrastructure teams would better serve their users if they were run more as if they were external products, but that unfortunately doesn't tend to happen for many different reasons.
Yeah, that makes a lot of sense because if I understand correctly, when you're building for an internal organization, you could have an offering that works, providing real business value and people are hosting their applications on it. But there's like little either developer experience issues or maybe there's occasional reliability problems and people have to go in and deal with that either in your team or from the application team. But maybe it can be hard to get the people assigned or the resources assigned to go like, hey, let's solve this once and for all because it's annoying, but it's not stopping the business. Whereas
that's 100% exactly the thing. So like an ongoing thing at all large companies are like migrations. So there'll be like the business critical migrations that will happen, but there won't be the less critical ones. There'll be like any large team will just have like a pending backlog of like, oh yeah, we want to migrate to this like new framework, this new, this better tool, this better thing, but they will just like never have the time or bandwidth to get to it.
And with the case of something like Render that's to the public, if you release a feature or an offering and it has like kind of shaky developer experience or it works 90-something% of the time, then customers are just going to go like, I can't use this.
Yeah.
They're not going to deal with it like an internal company might.
Exactly. That's exactly the kind of constraints and incentives.
I wonder also from the perspective of monitoring, your platform as a service or your internal teams at Stripe, is that different monitoring internal applications versus monitoring workloads that are coming from, who knows where you have no visibility into their source and things like that?
I think for the most part, it looks similar, but then there's like similar vectors to what we talked about earlier already, right? We have to actively monitor for people violating our terms of service or using our platform for fraud or abuse or using our platform to be the source of phishing or DDoS attacks for other people. You don't have that problem with an internal team because that's just not going to be a problem. So I think there's a much bigger vector of misuse of an external platform that you have to monitor for, put in safeguards against, than you do with an internal platform. So there's a kind of like a walled garden versus like the general bazaar sort of problem that you have.
How are some ways you deal with the unknown aspect of who's coming to use your service, whether it's for malicious purposes or someone's trying to just tie up your resources and not be like a regular customer, that sort of thing?
I think that's where we basically, all of this is monitoring and solved with all the tools at our disposal. So it's sort of so we have the kind of the basic monitoring, like monitoring of all the critical components, monitoring of all the resources, monitoring user signups, to the extent possible, everything that's automated. And then the other angle is there's an ongoing effort, which is truly never ending, which is fraud and abuse monitoring. So that's, again, it's automatable. And actually this is not in the sense that this isn't not a problem for companies like Stripe. It just comes in at a different space, right? There people are trying credit card abuse and fraud. So it's actually kind of interesting where the same sort of tools actually get used. Like Stripe isn't manually verifying, credit card abuse. So it's similar. You can programmatically monitor for people signing up, for fraudulent reasons or with stolen cards or are using phishing attacks and stuff like that. So it's always a mix of, automating that monitoring and automating the action that you take for the monitoring, and then always having the fallback for there is also sometimes a manual element for a lot of these things. So the CEO of Render was the head of risk at Stripe. So he is very familiar with fraud and abuse and handling it. And so he'll often take the front seat in these discussions because he's kind of, done it for this axis. And so it kind of, it's kind of interesting how much of that translates and also how many of the same tools we can use to detect fraud.
Another thing I thought we could talk about is when you're building a platform as a service or you're building an internal compute team, what type of expertise are you looking for? And is that different than somebody who's building a software as a service, for example?
I think broadly, I don't think they're that different. I think in tech, especially, the landscape changes so quickly that what you really want is people that are able to kind of be flexible and learn new things quickly. And kind of like an example, most of the stuff that I learned isn't a relevant skill anymore. The kind of, the code that I originally learned to program and just isn't useful. Sure, there are some places still doing C++, but that isn't mainstream. It's still a very widely used language, but that's not today's startups being built. So I think in general, you just want people that are really good developers, have a lot of curiosity and have a lot of kind of willingness and desire to learn, which usually kind of, goes with curiosity and humbleness. So, not assuming that they have all the answers and not kind of coming in with the mindset that, hey, I am an ex-developer with this much experience and I know how to solve this problem. And kind of coming in with, yes, I have these skills and how do they translate here? I would just say that that's kind of always the unifying characteristic for good engineers. And then depending on the specific problems that the team or the business is trying to solve at a given point in time, that's when you kind of want to delve into more specialized skill sets. So typically the skills that we kind of want to hire for at Render are not that different from what I would have hired for on my old team at Stripe. I think the difference is a little more on the adjacent sides, where I also actually think that we could have used some of those skills on my old team. And a couple of examples are design. So, having like dedicated designers, which we did not have on my old team. We kind of like, consulted with the Stripe design team, but we didn't have like an embedded designer. UX engineers, so people that are actually thinking deeply about the user experience and the workflow. We did not have that, though we actually had a few people who were very talented at that without that training, but just were like full stack engineers. And then a couple of other things that if I were to go back in time, was a dedicated support team. So we have that at Render because, and that's kind of where the difference comes in of being an internal versus a public platform. So at Stripe, it was actually the engineers on the team that would act as support on a rotation, basically. And at Render, we also have that rotation where actually everyone participates in support, but there's a steady team and a rotation, both. I think the key difference is you kind of go deep on special skill sets, typically user-facing skill sets on a public platform, which you don't do on an internal platform. But actually having seen both, I think that some of these deeper expertise areas could actually be taken back to internal platform teams, and they could actually benefit from those.
I mean, when you think of internal teams at any company, they sound like they should be different, but you kind of are saying like you really should treat it more like a product, more like something you are shipping to customers, even if it's internal.
I think we'd have happier users if we did that.
I also wondered too, when you first started at Stripe, how large was the compute team's team?
It was pretty small, actually. If I remember correctly, it was just around 14 people. So we were just starting to split the team. So I kind of came in, inherited one half of the team, one half of compute, which we called cloud, which was the layer that worked with the cloud providers. And the other half was called deploy and orchestration. So it managed the deploy workflow and also the orchestration layer. So we kind of like split it between, I believe, 6 and 8 people between those two teams. And I started with that. And then I think by the time I left, it was like, 4 teams and a little over 40 people.
And looking at how things were managed when you first started versus when you finished, as well as how things look at Render, I wonder how you approach the process of running a compute team or running an infrastructure team as it grows.
I think a few things I've kind of learned is because I kind of got to see things at a larger scale. Things like I have a kind of like, somewhat of a foreshadowing of, this is, we are going to be hitting scale limits or reliability limits, or even on the people side of like, this kind of experience of when to start splitting the teams. Like, what makes a good size team versus what kind of doesn't. So there's a bit of things that I've kind of leaned on from my previous experience, like such as, incident management, thinking about reliability and thinking about incidents and learning from incidents and actually being proactive about those, which I think typically will take larger companies. Like, there's like almost like a certain point in their life when they start learning about it. And I like to think that maybe because of my experience of seeing it at a larger scale, I have learned to kind of, start sooner than absolutely needed, but that kind of thing benefits us. There's an element of also like, just ecosystem experience that kind of comes in, like, vendors and like who do our users care about, that comes with having done it at a slightly different scale.
You mentioned how when the company is large, you built out this formal process for incident management and things like that. I wonder if there's anything else you can think of that is typically in place at a large organization that you think would really benefit a small one.
I think observability is another one, because that kind of goes hand in hand with reliability and incidents, which where I think that most SaaS companies typically wait longer to kind of, build out robust observability. And I wouldn't say that we are there yet either. I think we are still getting there. There's this kind of intangible just being really, really good operationally that companies learn as they grow. A lot of it is stuff around incidents, reliability, becoming much better about observability, better about like rigor, about stuff like this. There's an element of rigor around quality that typically comes in at larger companies, but there I actually was very pleasantly surprised that Render was already ahead of where I expected it to be. But just generalizing, I think that's typically not something that smaller companies will invest in. Security is another one that typically companies wait a little longer to invest in, that I think smaller companies would benefit from kind of, getting that expertise built in early, especially if you're like, in a more platform or enterprise product space.
When you talk about quality within the context of software, are you talking about code quality or defects, or, what are you referring to when you mention that?
All of them, but like starting with like quality, right? Like, So when I say I was pleasantly surprised, I was pleasantly surprised to find that as a default, most code at Render gets reviewed. There is a good rigor around code reviews and feedback and like, thinking about code before pushing it. That's not just for like quality, but just also like, for learning and collaboration. I think it's just so powerful. So that was a good thing. And then I think, then there's the defects and pushing it. And then at the other end of the defect spectrum is the incident, right? Like basically incidents are basically defects that are so critical that they cause an incident. So it's that whole spectrum between the writing of the code to how you deal with incidents and operationalizing that entire pipeline.
When you talk about improving quality, a lot of times that's related to making sure things work, whether they're tested, things like that. In the case of a platform as a service like Render, your platform is running the software of other people whose software you don't control, right? And I wonder if, as a part of your testing process, how do you account for that? Are you running random applications against Render, things like that?
I think we don't typically have to do that just because, there is enough of an abstraction between what our users are doing and what we're doing that we don't have to worry about that. What does happen, though, there will be an interesting series of support questions that will often come in where users are kind of struggling to deploy something, and it will not always be clear whether the problem is in their application or the library that they're using or actually on Render, and that gets tricky. And actually, interestingly, that is not unique to the public platforms. My old team at Stripe had this all the time as well, where, people would come to the compute team and ask for help debugging because they had literally gone through the entire stack and often try to debug, and then we were like the last layer and we would often end up helping them debug their application problems versus it not being our infrastructure problem. So I would say it's not actually something that we have to test as much, but it's something that we definitely have to be prepared to answer questions about. And then often it is also there's always this interesting kind of question, like we might be able to help them, but also what is our level of obligation? So we generally try to be like good support and do try to help them, but there's also at some point we have to also tell them like, hey, look, actually this is a problem with your application and you might need to fix it.
It's a reminder that you aren't a consulting service. You're a platform to host your application.
Yeah. Versus as an internal platform, you often cannot actually say no. Or usually people don't feel comfortable saying no because in the end, you are one larger team, and that's where the incentives are a little mixed.
Let's say you're fielding a support ticket for your internal team and someone's saying, I deployed this app and it's not working. Would your support team actually have to go in and look at users' code and things like that?
You mean for the internal team, right?
Right.
Yes. And that was very often the case. And this was a mix of one is because you're part of the same larger team, you kind of have this obligation to help your coworkers. And then the second problem is also because you haven't typically had the luxury of building those strong interfaces from the get-go. It's actually hard for your users to know where the problem lies. With a public platform, you have built strong enough abstractions that you can quickly debug and tell your users that, hey, no, actually it's there and this is exactly why we think it is. With an internal team, often the abstractions are leaky and it might not be easily obvious. And that's kind of where I kind of was alluding to the fact that internal platform teams could be likely better off if they had those stronger abstractions and those stronger boundaries.
Could you give an example of where those boundaries leak in an internal application?
One example is, which was kind of quite painful for my old team, was we were using this service mesh library called Envoy. My team had kind of done the migration, kind of rolled it out. So all internal service-to-service communication was through Envoy because Envoy provided, stronger security guarantees and more observability. But when it was first rolled out, it was kind of, migrations are always a bit rough, so it was still new. So there were problems with the migration itself. But then it kind of also led to this narrative where a service would fall over people would quickly look at the logs, see an Envoy log message somewhere far down in the stack and be like, hey, we have an Envoy problem, and my team would then have to kind of debug it. And this is that same thing where the abstraction leaked because it wasn't built to be strong. There wasn't a strong enough abstraction, but then there was also this kind of problem of guilt by association where we would kind of end up debugging things or have this problem. And I think this is just a very common problem for internal infrastructure teams where they end up debugging things across the stack.
Yeah, that's really interesting because it's a little counterintuitive where you would think oh, we both know about this thing, so, it'll allow us to work better together. But in the case of Render or any other platform as a service, the user will never see the Envoy error. They'll never see all these things that are happening in the background. So they can't go to you and say well, clearly it's your problem, right?
Yeah. And you also aren't sitting one desk over where you can just be tapped on the shoulder. And your 3 levels of manager isn't the same manager.
Totally. Yeah. So it's a culture thing there too.
Yeah. Yes, absolutely.
Well, I think that's basically everything I had, but is there anything else you wanted to mention or thought we should have talked about?
One kind of pet hypothesis that I'd kind of like to offer, because we talked about incidents and we talked about compute, is maybe there's kind of going to be this expansion of products that are essentially going to be replacements of things that internal platform teams have built over the years. So I've kind of tweeted about this a bit in the past, but I think it's my current pet theory about how the platform as a service space is going to expand. We're on this current evolution where all the developers that work at large SaaS companies have gotten used to a certain set of tools that they will now either build themselves or want to see built. And that's where the ecosystem will kind of head next. So that's kind of, I guess, one hypothesis I would like to let out in the wild.
Are you picturing something where, maybe 5 years from now or something, somebody would go to Render and they say, I want to build an application, and Render will have here's the way that you log in your application, and here's the dashboard. You plug in some maybe configuration and we'll set it up for you. You've already picked these specific products, I guess, or ways of doing the things that nearly every application is already doing.
Yes. I think for Render's case, that would kind of be a bit of the next step. I think there's also this element of we'll kind of, see this next layer of basically platform as a service or almost services as a service. So an example would be, we'll see more managed database companies come up. We are already in the space, but that's not our core competency, but we'll see more and more managed DBs. People will push more and more stuff down. Each large SaaS company has a whole plethora of internal tools that they use, and each of those is almost its own product, for instance. And we will see more of them kind of coming up and existing, where there will be a way to kind of, stitch together different tools and provide them like Zapier does or Retool is trying to provide, or at the lesser kind of degree things providing SOC 2 compliance, it's now becoming a product or something. So compliance is becoming its own product, right? Or you're seeing companies exist that are providing incident tooling specifically. So you have Jelly, they're doing learning from incidents, or you have Incident IO where they're providing incident management. So all of those will kind of become standalone products in themselves. So you as a founder could take out your credit card and sign up for Render plus these 2 other tools, and things that you would have done with engineering effort will now be done with your credit card.
Well, I hope we get there, because I think there is so much, I suppose you could say, brain energy being used on every time somebody creates a new application. They have to decide, okay, what are all the services I'm going to use and what am I going to do myself? And if somebody could just hand you, hey, use these things, we've configured them for you, you're all set. That could save so much time.
Yes. I think that is 100% something this kind of a startup kit of SaaS companies. I've seen a few of those actually floating around already, but I think it'll become more kind of canonical.
At Collide, we know end users are IT admins' most significant untapped resources and key to solving the most challenging to fix security issues, including instructing developers to set passphrases on unencrypted SSH keys, finding plain text two-factor backup codes and teaching end users how to store them securely, convincing employees to uninstall evil browser extensions that may sell their browser history. Visit collide.com/SERadio to sign up today. That's KOLIDE.com/SERadio. Enter your email when prompted to receive your free Collide gift bundle after trial activation. You can try Collide with all its features on an unlimited number of devices for free for 14 days. No credit card required. Try it out at collide.com/SERadio.
To wrap up, where can people find you? Where can they find Render and anything like that? Go for it.
Render.com. Check us out there. Or reach out to me on Twitter. I'm on Twitter. You can just follow me or reach out via DMs. Also on LinkedIn if you're more old school.
Cool. Well, Uma, thank you so much for joining me on Software Engineering Radio.
Thank you so much for having me. This was a great conversation.
This has been Jeremy Jung for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.